Alright, so in this section, which is section 1.2, we're going to talk about classifying and storing data. However, before we start talking about that, what we need to talk about is we need to talk about the difference between a population and a sample. So when we collect data, we usually do it from a large population, so that would be the group that we're interested in, and we put them into a collection, which we call either a data set or a sample. So an example of this would be, let's say we're interested in all U.S. males 18 to 35, and we observe all males at Olympic College. Okay, so we're interested in this really big group, which would be all U.S. males between 18 to 35. Now, actually getting data for all U.S. males 18 to 35 is not possible. Like, we have some that aren't registered with any government or official entities, things like that. So what we do is that we take a small subset or sample of them, and we observe all males at OC. So the population is the one that you wish you could look at. The sample are the ones that you actually look at. Okay. The next thing we're going to be looking at is something called a variable. So a variable is a characteristic of people or things. So for example, a car can have the characteristic of weighing a certain amount, and a person might have characteristic of having blue eyes. So in this example, if we wanted to include a variable, let's say we're interested in, well, you can't just be interested in every single aspect of a U.S. male. Let's say we're interested in the height. That would be a characteristic. Okay, so that would be a variable. Now, when we get to variables, we're going to have two different types that we're going to be talking about. A variable can either be numerical or quantitative. So that's going to describe the quantities of something. This could be something's weight or its length. Now, a category, which is called qualitative data or variable, describes qualities of the object. So these are also going to be categories or descriptors, but they can also be numbers. So an easy way to tell the difference is if you can add observations and they make sense, then what you have is you have numerical. Okay, so let's look at the next example. And let's say that we want to decide if a variable is numerical or categorical. So what I've done is that I've taken 4 of my friends and I've ranked them 1 through 4 as my closest friends. I've described whether or not they're employed, how much they weigh, their height, and their gender. So first off, gender would be considered categorical. Height would be numerical, because I'm talking about how many inches tall they are, so how many, that would be a sum. Weight, how many pounds, so that would also be numerical. Whether or not they're employed, that would be categorical. And last but not least, rank as a friend. Well, is this one numerical or categorical? So here's the test. If I take my number 2 friend and I add them to my number 4 friend, I get my 6th ranked friend. But see, that doesn't make sense. The reason that doesn't make sense is because I might only have 4 friends. So in that case, this would be categorical. Another note is that I could have described their heights not using a numerical, but using a categorical. So height could have been categorical if I had done it in the following way. If I had described them as tall or short. Or what I could have done is I could have created bins. So maybe I put my friends who are 5 feet to 5'6" in a bin, 5'7" to 6 feet tall, etc. Okay. Now, sometimes it's a lot easier to use numbers instead of written words, and what this is called coding. So, for example, instead of writing yes, no, or for example, if we're doing right and left-handed people, instead of writing right, left, right, right, we code it using 1, 0, 1, 1. Same thing here. Blue eyes, instead of saying blue eyes, brown eyes, green eyes, maybe we're only interested in the number of blue-eyed people, so we use 0 for no and 1 for yes. So 1 can be thought of as a yes. You can also code using 2s or 3s. Usually you'll see it as a yes or no answer though. All right. So let's stop and do a big example real quick just to make sure that we understand the following vocabulary. So let's say that we're interested in the crime rate and rank of each of the 50 United States. So what we do is that we obtain the following information. In Alabama, the crime rate was 425 and it ranked 23. Alaska, 688 at 6. California, 533 at 14. Idaho, 247 and it ranked 42nd. So here's the thing. Suppose we are interested in, so this is a big thing we're interested in. We're interested in the crime rate and the rank of all 50 United States. So, since that's the big picture I'm interested in, my population would be all 50 United States. Now, when I actually got my data, I didn't get it for all 50 United States. I only got it for these 4 states. So my sample would be Alabama, Alaska, Cali, and Idaho. Now the variable type would be the characteristics I was interested in. So I am interested in the crime rate and the rank. So rate would be numerical, while rank is always going to be categorical. Okay. What do we call the numbers in the table? So if we look at the numbers in the table, what those are they are a record of observations, so they are called data. Now, the key thing in statistics, and I would like to argue in science in general, is that numbers or information doesn't mean anything without context. So if we look at these, a couple questions that we might want to know is what crimes are we looking at? Okay, so are these arsons? Are these murders? Are these thefts? Are these misdemeanors? Right? Another thing that we might want to know is how does the ranking work? So if Alabama is ranked 23, does that mean it's the safest? Does it mean it's the most dangerous? Like, I might be able to gather some information from these, but I'm still not really sure. The other thing is that it says it's a rate. So it's 425 out of how many citizens? Is it that there's going to be 425 crimes per 10,000 citizens? A million? Okay. And there's a plethora of other questions we can ask. I'm sure you guys are going to come up with some great ones. But this is just to get us started. So what else might we want to know? We want to know some more context. Okay. The next objective we're going to talk about is how we store our data. Now, we're going to have 2 different options for storing our data. One option is going to be stacked data. Okay? We can tell that data is stacked because each row is going to describe a single person or object. Okay? And then each column represents a variable. Okay? So remember, columns go up and down, rows go left to right. Okay? The way I remember that is that columns are the things that keep buildings up. So yeah. Here, we're looking at some data collected from a sample of frogs. And in that sample, we have the weight and the diameter. Okay? So if we look at this, we want to know, does the row describe a single observation, aka a single frog, or multiple ones? So this would be a single frog that has a weight of 6.1 grams and a diameter of 12.7. So this would be considered stacked data. So having data in stacked form is very useful, especially when we get into chapter 4, when we get into correlation. All right, now unstacked form is where each column represents a different group. Okay. As well, we can tell that this is stacked because if we circle a row, these are talking about two different frogs. So two frogs. So it's talking about a frog that belongs to species A and then another frog that belongs to species B, means that it's unstacked. This is useful if we wanted to compare one species to another species. Okay? The downside to unstacked data is that we can only store two variables at a time. So, for example, let's say that we're looking at pizza toppings and we have pepperoni and cheese, and we also have Hawaiian pizza. And then we ask different age groups which one they prefer. So let's say that we have a 13-year-old that likes pepperoni, a 7-year-old that likes cheese, a 30-year-old that likes Hawaiian. We have an 18-year-old, we have a 15-year-old, and then for Hawaiian we have a 25-year-old, and let's say we have a 28-year-old that also likes Hawaiian. Okay? So we actually only have two variables here, even though we have three categories. So one variable is pizza, and the other variable is age. So even though these two have multiple observations that can go with them, they're two different variables. So let's see, we have pepperoni for the 13-year-old, we have pepperoni for the 18-year-old, cheese for the 7-year-old, etc. Okay, so this would be an example of unstacked, while this would be an example of stacked. Because this has three people, a 13-year-old, a 7-year-old, and a 30-year-old. This is stacked because we're describing one person who likes pepperoni pizza and is 13. Now, here's some important questions to ask whenever you're observing something. Remember, context is key. Okay? So, one of the things we want to know is who or what was observed, what variables were measured, how did they measure them, what units did they use, who collected the data, how did they collect it, where were they collected, why were they collected, and when were they collected. So, there's more questions that you'd like to ask, but these are the big ones. So, what I would like you to do is I would like you to pause the video and come up with some questions you would ask about this example. All right, so what happened is that a study of grass height was done, and density per square inch, in 1998 and sponsored by Bradley's. So what they did is that they collected the information below, and we just want to tear it apart and talk about why it is and isn't a good study. So one of the reasons that I found this was a poor study is because grass height has no unit. So there's no unit here. So is that 3 inches, 3 centimeters, 3 feet? Is it how much it grew? Is it, did it grow from a seed? Is that just how much it grew from the last time we cut it? The other thing is that it was sponsored by Bradley's, so I feel like there's an inherent bias here. Okay, another thing that I find interesting is that they didn't have a control. Now, what a control is, which we'll learn a little bit later, is a control is when you have something free of your experiment. So for example, they're testing fertilizer, so they're testing Bradley's and they're testing the competitors, but what if both of them are actually bad for the grass? So no control means that they have no base for comparison. All right, and let's just throw one more in there. Okay, they also didn't tell us where or when the study was done. So they told us it was done in 1998, but was it done in the winter? Was it done in the fall? Was it in a controlled setting of a greenhouse? Was it in California? Was it in Nevada, for example? A lot of these things matter, as well as if we looked at Bradley's and the competitors, were they grown in the same place? So I'm sure that you guys came up with a lot of your own questions tearing this apart, but those were just a couple that I wanted to point out. So next we're going to look at section 1.3.